Hello everyone, I'm Lakshmi and today's seminar is on bash scripting. So what is a bash script, or a shell script as it's also called? It's basically just a plain text file with a series of Linux command line arguments, such as ls, which stands for list, and cd, which is for change directory, or cp, which is for copy. All these commands can be directly keyed into the terminal's command line, provided each command is separated from the other by a semicolon. In that case, why bother with a script? Well, firstly, when you have a long sequence of commands where each one depends on the result of the previous command, it gets cumbersome typing a whole block of text into the command line. It's neater and easier to debug if you package it all into a script. Also, once it's packaged, it's reusable and you don't have to type it all out every time you need to use the same routine again. In the seminar, we'll start by running a simple bash script just to get the ball rolling. We'll then go through the essential components for building routines, such as variables, conditionals, and loops, followed by a few important commands to interact with and modify files and folders. Lastly, we'll go through what we need to do when we put them all together. All right, let's dive straight into it. First, launch your terminal. It looks something like this, a big black box with $signs here that indicate where you can type in your commands. To check where you are, you can use the command pwd, which stands for present working directory, and it'll return the path to where exactly your terminal is currently located. To make a new directory for this seminar, you can use mkdir, which is short for make directory, followed by the name that you wish to give for this directory for the seminar. I've used toolkit bash. To change into this directory, use cd for change directory, followed by the name that you've chosen. There are many text editors that you can use, Vim, Emacs. So I personally use Vim. So this is a quick cheat sheet so that you can create files using Vim. So to create and open a new bash script, you write Vim followed by the name of the bash script. Now here, the .sh extension indicates that it's a bash script. This is not necessary because Linux doesn't need extensions to identify the file, but it's good practice so that you as a user know exactly what this script is, that this is a shell script and not just a plain text file. So once you've opened up the Vim file, you get a blank screen, and to start inserting text, you press your I key in the keyboard, which stands for insert mode, and then you can start typing in whatever text you want, the commands of your script, and when you're done typing that and you want to end the insert mode, you press the escape key. Once you press the escape key, nothing else you type on the keyboard will be added to the text. To save your edits, use :W, and to quit your editor and return to the terminal, use :Q. If you want to quit without saving your edits, you add an exclamation mark after the Q. So now you know how to use Vim, and you can use it to make your first bash script. So vim hello.sh, or whatever you want to call your first bash script, will open up a blank screen, and you type in what you see in this black box here is the contents, commands for your first bash script. So the first line you see here is called the shebang, and it must be there. Every bash script needs to start with this line, as that's what tells your computer where to look for the bash program to run this script. So it's always the syntax, a hashtag, an exclamation mark, /bin/bash, and every script needs to start with it. Otherwise it won't work. So that's standard. To add comments in your script, add a hashtag below. So apart from the shebang line, every other line in your script that starts with a hashtag is treated as comment and not as code. So here I've added the comment print to the terminal. It's optional, you don't need it because the comments aren't read. The actual command is echo, which in this case, which is the bash equivalent of print. So everything after the echo is printed out to the terminal. So echo hello world. And over here I've put exit, which is not necessary. It just marks the end of the script. But if it's not there, then the script just assumes that the end of the file is the end of the script. It's useful if you want to terminate the script prematurely and have further commands that you don't want to run in that particular round. So once you've added this text in, press the escape key, assuming you're using Vim, and :WQ to save and quit and return to the terminal. Voila, you now have your first bash script. So how do you run it? Well, you can run it directly by just writing bash hello.sh or whatever you call your script in the terminal. This is in the terminal, hence the $sign. You don't have to write the $sign, just write it after the $sign in the terminal. And this will run it. Alternatively, you can make it an executable by giving it the executable permissions. That's what chmod does. And the +x adds the executable permissions to your file. And after you do this, you just need to do this once. And once you've done it, you can run the file whenever you want with // followed by the file name. Note that running this file does exactly the same thing as directly writing echo hello world into the command line. It's just that we've packaged it into a script that you can move around the place and use whenever you want. And in case you've tried this out, then surprisingly, the output you expect is for hello world to be printed out in the terminal. Great, so now you know how to run a basic bash script. So let's learn a few more components so that you can do more than greeting the world. So first on echo, since we just saw that, we just saw how echo followed by some text just prints that out into the terminal. Now, what if you want to print into an output file instead, say out.txt, as I say here? Well, you use the right arrow, this or greater than sign, and write the name of the output file text. So this just creates an output file text called out.txt and writes hey into it. So if an out.txt already exists in the directory, this command is going to overwrite it. If instead you want to append to this file, you use double arrows instead. And this writes the line in the next line. So if you run this followed by this, you're going to get a file out.txt with hey followed by hey again. Variables next, because they are the building blocks of a code. So if you want to assign to numbers, it's as simple as write your variable n or whatever you want your variable name is with an equal to sign and your number. Make sure there are no spaces before and after the equal to sign. To assign to strings, you can use the quotes to mark the start and end of the string. Again, no spaces before and after the equal to sign. You can call a variable by using the $sign. Example, if you want to print a variable, write echo, the $sign followed by the name of the variable, and it'll print out, in this case, 1. To use another variable in the assignment of a new variable, such as, say, if I want to make file using n, which is 1, this is the syntax. Here, note that we use double quotation marks because here we're substituting in another variable. Again, you use the $sign and you have to use the curly brackets here to mark the start and end of your variable name. So this will again give you job_1 since n is 1. To cut out part of another variable, use the slash. So if I have a variable named file, and I want the prefix, which is job_1 without the in, I again use the double quotation marks because we're using another variable in this definition, the $sign and curly brackets and file, so that gives me the file name, and the slash means it cuts off and .in. So now I'll get the prefix, which is just job.1. So if you print echo $prefix, you get job_1, not dot, sorry, underscore. So take care and note here that when you're using another variable in the definition of a new variable, you always need double quotation marks and a $sign before you use the variable. Moving on to arithmetic. Arithmetic always needs double parentheses of these round brackets and a $sign. So if I want to assign m to 1 plus 2 I do m equal to, again, no spaces before and after the equal to, $, double parenthesis, and whatever function I want here. If I want to use another variable within the arithmetic, I can do so like this. So I assign n to 1, and I assign m here where I have n inside. Note that for arithmetic, since you already have the $ out here, you don't need the $ inside. You can directly just use n, which is slightly different from when you directly use the variable n. If a variable is set to a character string, then it just takes its numeric value to 0. And the symbols for subtraction, multiplication, division, modulo are as follows, as shown here, the usual ones. Moving on to conditionals, the syntax for conditional is if, and then square brackets where you insert the condition. Semicolon means next line, so if you're writing them in one line, you put the semicolon, but if you have a script, you can just move to the next line. You have to write a then before you write whatever you act in case of this condition. If you have an else, you put the else there and put what you do if the condition is not satisfied. And you have to end with a phi, which is just the flip of f. So it's all symmetric. The if here and the phi here. And then there's a then and else indicating where you're doing what action, for which condition you're doing what action. So there are many conditions that you can check. Here are a few. So if you want to check if two strings are equal, you just use an equal to sign, not the double equal to as many other programming languages do, just a single equal to will do. If you want to compare integers, you use the -eq. And the corresponding inequality checks are exclamation mark equal to and -ne. Note that if you have 001 equal 1, it returns false because it's treating them as strings. On the other hand, if you compare them using -eq, it treats them as integers and so returns true. And also note you need a blank space between the square brackets and whatever you write inside, otherwise it will give you an error. The symbols for greater than, less than, and or are as shown here, which are -gt, -lt for lower than, and sign for and vertical bars for or. Finally, loops. Well, you can loop over lists or ranges. So if you want to loop over a list of strings, you can initialize the list like this. So here, colors equal to, again, no spaces between and before and after the equal to, and just put quotation marks followed by each word in your list. This gap lets it know that it's a different element. And then you can loop over these by just doing for c in $, because you're referring to this variable list of variables. I mean, the colors is the variable here, so $, and then do. This is the important part in the syntax. So it's for, do, done, as said, and as it's written here in the title. Then do what you want to do here. I'm just echoing the name of each color, and then to indicate that the for loop is done, you put done in the end. You can also loop over ranges, and the syntax for that is using curly brackets with start, double dot, stop, double dot, step. The step, double dot, step is optional, so if it's not given, it just assumes a step of 1. So here, this would be 1 to 6 with steps of 2. So that's 1, then 3, then 5. Note that the ranges are inclusive of the start and stop. So it always starts with 1. And if step of 2 hits 6, it'll include 6 as well. So now that we know how to make protocols of commands, let's learn a few important commands to interact and manage the files. Here are a few commands to scan the terrain of the current directory that your terminal is in. To list all the contents of your current directory, you use ls, which is short for list. Now, you may not always want all the directories. Say you want only the directories that have a certain tag in their name. You can do so by writing ls star tag star, which says that anything, the star is like, it stands for anything. So anything that has tag in it and ends with anything else and is included in this list. So it will return all names that have tag somewhere in it. The tag could be in the beginning, the end, or somewhere in the middle. And tag is just a placeholder. It could be some number or some string that you've used to label all the directories of your project. Now, to count the number of contents that list returns, we use the piping operator, which is this vertical dash. So first you have ls, and you have this piping command, which means that whatever follows it acts on the outputs of this. So ls returns a list of all the contents. The piping command takes this list, and wc-l is the syntax to count. So wc-l counts the number of contents in the list that ls returns, and so this combined command basically gives us the number of contents in the current working directory. If you do ls star tag star followed by this piping operator wc-l, it will return the number of contents with tag in their name. To assign the contents to a variable, this is the syntax where you use the $ and single round brackets. This is different from arithmetic, where we use double round brackets. So n, again, no spaces before and after the equal to, $, single round brackets, and the command is in here. And this will return, this command counts the number returned by list, and that number is assigned to n. Now, here are some standard commands that you're probably already familiar with for managing files. So say you have two variables, file1, which is set to this string here, inputs underscore one dot text, and file2, which is inputs underscore two dot text. So if you want to copy file1 to file2, you use cp, which is for copy, file1 with a $ because it's a variable, and file2. So this copies the first file, the position you put in first, into the file that you've put second. The syntax for move is very similar, just that you use mv instead of cp, where mv is short for move. And the first file will be moved to the second file. And after running move, this file will no longer exist as all its contents have been moved to file 2. Whereas in copy, both files will still exist. It's just that you've made a copy of the first one. To delete a file, use rm, which is short for remove. Now, to navigate between directories, these are a few commands. Say that you have variable f, which is assigned to job_1, a name. If you want to make a directory with this name, you use mkdir, as we saw previously, short for make directory, $f, which calls this variable, and so make a directory with the name job_f. To move into this directory, you use cd, which is change directory, followed by the name of the directory, or the variable, which shows the name of the directory. And to move back to the directory above, you use ... which moves to one level above in the directory architecture. To remove a directory, let's say called dir, this is the name of the dir, it's not a variable, and it has contents. So you use the -r, which stands for recursive. So it recursively removes the directory along with all the files that are inside the directory. If the directory is empty, you can just use rmdir, which stands for remove directory. Now, a few more slightly trickier but very powerful commands. First one is grep, which you can use to check files. So say you've run hundreds of simulations, each in its own folder, and all of them have an output file, out.txt, and you want to see if a certain tag that denotes that the job is converged or not. You want to see if it exists in each of these files so that you know which of your jobs have converged. So that's where grep comes in handy. So the notation is as such. It's grep followed by the tag, which is a string, or tag in this case is the string that we're looking for. But here is whatever, instead of tag, you put whatever string you're looking for, and out.txt, which is the file that you're searching for this string called tag in. Now you can count the number of lines using the notation we just saw by piping this output to a WC-L, and this will return the number of lines in out.text text that contain tag. Note that tag here is just a string, it's not a variable. If it's a variable, I would have put a $sign before. So here I'm looking specifically for this string. Now to save the results of this grep into a variable, we use the dollar and single parenthesis, single round brackets as we saw before. And you can also use grep in an if to check if the tag exists, and the notation for that is a -q. So grep -q tag out.text returns true if tag exists in out.text and returns false if tag does not exist in out.text, and that can be used in if statements like this, as shown here. And this is very useful to identify, say, if a file has the tag, you move it to a certain folder, and if it doesn't have the tag that you're searching for, you move it to another folder. So it's very useful for managing your files based on certain strings that you're looking out for. Another very useful command is sed, and I usually use it to replace strings across many files. So say you have a string which you call old string, and you want in a certain file called file.text, and you want to replace it with new string. So sed can be used to do that as sed -i, which means that it's going to make all the changes in this file. And the command is a quotation. You need quotation marks, s/the old string / the new string / within quotation marks, and then the name of the file where you're making this change of replacing old string with new string. To replace all occurrences, so this was just to replace the first occurrence. If you want to replace all, which is global, you add a G after the last /, still within the quotation marks. The I here, as I just mentioned, will change the existing file, so it will modify file.text. If instead you want to save the modified state to a new file without changing the original file, you have the same thing, and you have to remove the I here. Sorry, this is a typo, I shall correct it. So yeah, you don't have the -i here, and you use the right arrow to channel the output into a new file. There should be no -i here because the -i modifies the original file, and that's what we don't want to do in this line. And here's a quick trick if you want to apply grep or sed to all directories. So you have output files in all your directories. You can use the star. So say you have many folders, all named job_n, where n is 1, 2, 3, all the way to say 100, and each of them have an output file out.text or input file file.text, and which you want to modify. You can apply grep to all of them by grep, whatever tag you're searching for, by job_star, where star means anything that follows. So it can be 1, it can be 10, it can be 100, it goes to all the options. And you search for, in each of them, you search for their out.text and search if tag is in there. And the same with sed, where you, instead of just file.text, you have job_the star, which indicates all possible options. And in each of those directories, it looks for file.text and makes this replacement. So now we've learned quite a few components, and I think that for most of my work, these essential components are sufficient to make really powerful routines that can manage all my outputs very efficiently. So what can we do? Here are some examples of what we can do. So you can systematically generate input files for many similar jobs, think hundreds of jobs. Instead of manually copying each file 100 times, you can just write a quick, simple script and it'll do it 100 times for you. Similarly, you can automate the submission of large batches of jobs. If it's a very repetitive task, instead of going into 100 folders and submitting the job, just write a simple script. It'll do that for you. You can automate the process of checking which of your jobs have converged or not by searching for a certain string in each of the outputs. That if there's a string that indicates your job has converged, you just use grep and search for the string in everything, and it'll sort it for you rather than manually checking each of the files. You can also extract results from your output files using grep and saving the results to any text file that you want, instead of manually going into each output file and copying the line of interest. You can also modify across several directories using sed. So these are really powerful for workflows and to doing quick checks on your results rather than manually opening hundreds of files or copying hundreds of files. So now let's try some examples so that I can convince you that this is really useful for it. So you can find all the example files that I'm about to use in this Google Drive link. Do check it out and try them out, because doing is the best way of learning. I have these files saved locally, so I'll move to my terminal now and run through the different tasks out there for you. So this is my terminal, and I first move into the toolkit bash folder, and you can call it whatever you wish. And if I do ls here, you'll see that I have the hello.sh file, which was the example file I mentioned in the slides in the start, and a folder called examples. Let's go into examples. And ls for list, you'll see there are 4 tasks here, and each one, the .sh is because they're shell scripts, and they're the top of each of them, say, will have the task, and they need to be done sequentially, and it has a template which you can fill in to do the task. You also have a program here. It's a very simple program, which is also a shell script, but it doesn't have to be. Your programs could be a Python program or any other program. I just wrote a shell script because it's easy. So you can just look at the program, what it does. So this is just a program that checks if the input n, which is set in the start, whether it's divisible by 2. And if it is indeed divisible by 2, it finds a square. Sorry, there's a 2 missing here. It's n square, and saves the result of file called outtext. So you see here, it does that by finding the modulo of 2. And if the modulo is 0, that means it's divisible. So it echoes, this is divisible by 2. And it finds a square and writes square is equal to this. Whereas if it's not divisible by 2, it writes this integer is not divisible by 2 into the output file. It's a very simple program. So let's look at task 1. So what's task 1? So task 1 says we need to make this program.sh for input files for different values of n equals 1, 2, 3, 4, 5, 6, and each of them in their own distinct folder named job_n, where n stands for 1, 2, 3, 4, 5, and 6. So let's give it a shot. So first, let's set a program name. I call it fproc equal to, our program name here is program.sh, so that you don't have to keep typing it again. So the next one would be to loop over your input values. So the syntax is for, I call my input variable n, in, use the range syntax here, we have 1 to 6. And the step size is 1, so you don't actually need it because that's the default. And then you have do, and at the end of your for loop, which I've given you a clue here with indentation, you need a done. So I usually write that at the start just so that I don't forget it. So now, for each value of n, you set your folder name. So what's your folder name going to be? It's called my job_n. So I set it to a variable called dir. And I'm using a variable in this definition, so I need double quotation marks, job underscore, and now I'm using the variable, so it's a $sign and curly brackets since they're inside double quotation marks and n. So this gives me the name job_n, where n runs for these values 1 to 6. Now I make the folder. The command for making the folder is mkdir, and I use a $sign and do. So for each folder name, I make the directory. Now I copy my program into this folder. I do that with CP for copy, and I call the variable storing the program's name, and I copy it into the directory. And next, I have to modify the input value in this program. So how do I do that? I do that by using sed, and I use I because I want to modify this existing file, and the file that I'm running is now the file inside the directory, and it is called fprod. So this is what I'm running it on. And now the syntax for sed is you have these quotation marks, you have an s / g for global, and here is the string that you want to change, and here is the string the new string. So the string that we want to change, we saw program.s is everything is saved as n equals 1, and we want to save them to n equals this variable n. So this text n doesn't matter because it only treats it as a variable if you have a $sign. Now, there is a mistake here. What is it? Because I'm calling a variable inside, I cannot use single quotation marks. I have to use double quotation marks. Only then will it recognize the variable. And now you see when I use double quotation marks, the coloring changes and it recognizes that n is a variable. Notifying the user is optional, but I like to do it to see where my program's at. So I can, what should we notify? Let's say that use double quotation marks to use the job and say folder, and let's call our directory name D, and that's the end. And this should do it. So we are, for each value of n, we are creating the directory name to this variable. We make that directory. We copy our program from our current directory into this directory. Then we apply sed to replace the input variable line in that file to the line that we want for the program inside the directory and not the one in the current directory. So you've already copied it over. And then you echo to the user that it's done. Now let's try this. So I have bash and task1.sh. And you see it run. It told me job 1, 2, 3, 4, 5, 6 are done. And if I do ls now, you see it has job 1, 2, the folder for each job. And each of them should have a copy of this. So let me try ls job 1. Yep, it has an ls job 2. Yep, it has program.sh. So let me check, open up the program in job 2. Yep, and you see n is equal to 2 here, as we set it with the sed. And what about job 3? Is that correct? Yes, indeed, its input file has n equals 3. So you see, with one click, you could make all 6 folders. And if you have hundreds of jobs, this is very useful because you don't want to make each directory separately. Just write this simple task, this bash script, and it does it for you. So there are other tasks here, tasks 2, 3, and 4. I think I will leave you to it. I'll just show you what the tasks are. So task 2 is to run program.sh in each directory. So this is a shell program, so you run it by just doing bash program, but you have 6 directories. So basically, you enter each directory. I've given you hints here, and then you move into that folder, run the program, and move back out, and then you do that loop. Okay, you can try it out. So task 3 would be, now that you've run all the folders, you should have an out.txt in each of them. So in this task, what you do is you search for a certain tag, whether it's divisible or not divisible in the output files of each of the directories, and you categorize them. So the ones that have divisible in their output, you put them in folder div2, and the ones that are not divisible, you put them in not2. So I have some comments here that will help you along. And the last task is to just extract the square for all the ones that are divisible for 2. So when we look through the program file, if you remember, we print square, the square in the output file for all the jobs where n is divisible by 2. So you just want to extract that line. So, oops, the solution is here. So yeah, you can use a quick grep. I shall remove the solution from the files that I upload so that you can try it out. But as you can see, it's a very quick line. Just grep and search for square, and it's going to give you all the lines and the paths to those files which have square. And you save that to a file called square.txt. So you just need to open up square.txt and you have all the results there for you instead of going into each file and doing it. So I'd recommend you try these tasks, and you can find all the solutions in this solutions folder. So less solutions, you see the solution, my solutions for each of these tasks, so you can check against that to see if you get stuck anywhere. And that's it for now. It's quite a lot of content, but hopefully it wasn't too overwhelming. Do try out the other 3 tasks and the examples. They're very easy tasks, and it'll hopefully be of help for you and help you automate many protocols in your projects. It definitely has helped for me. So thanks for listening, and feel free to ask me any questions in the comments below. Bye-bye.